Hello everyone. I'm going to talk to you today about the convergence of runtime and posture security. Gary made such a great intro, so I cannot really add here too much. I just wait a second. The slides are going just a little bit fast here. Just something to add. I used to be on the offensive side of the security. Then I moved more into product and defense part, and I think for the last 10 to 12 years, I've making security products. And I feel really that if we are looking at past, I don't know, 30 years of security industry, there have been different changes throughout the time in these last 30 years. Sometimes it's hard to admit that how long I've been in this industry, but then how many things I've already seen. But there were different phases of the world and for security industry, and I want to go through with you together to have an overview, which will help you understand why we are getting to the place where we are getting as an industry. And then I'm going to show you a few examples of the convergence you saw in the title of my presentation. So, as you well know, most of us who somewhere here and there see in the 90s what security products meant in the IT world was mostly around firewalls. Firewalls here and there, and they evolved into the early 2000s also into something more complex. But this was the product for the security teams. So if you had to think about what is information security, and I'm really talking here about in the big picture, in the big perspective, information security was mostly around network security and around the classical Alice wants to talk to Bob throughout an unprotected connection kind of thing, which brought us into the internet world where we were just simply afraid of who's connecting our computers in our organizations. Then firewalls came into the picture, and firewalls became the product the security team used in everywhere in order to protect the assets of the organizations. Now we got into the 2000s. In the 2000s, there was a shift for multiple reasons. Obviously, a single presentation could also just only talk about why we moved into the endpoints. But as in general, for many reasons, attacker understood that it's not that easy to just simply hack into the network system of an organization, and looked for other lower hanging fruits. Endpoints became those ones. Endpoint security became more prevalent. Endpoint security products in the 2000s. So an uprise. Also, again, I'm a little bit, trying to categorize here and over stereotyping things. But most likely, most of the time, when we talked about in the 2000s, we talked about new hot endpoint products that came into the world, and obviously this thing went into the 2010s as well. But the security teams now around the 2000s, at least they have two products in their hand. One is firewalls and everything around that, and endpoint protection systems. These were the two things that they had. Both of them worked on live systems, preventing attacks in live systems, something that we would call something like runtime security. Now, in the 2010s, we saw the cloud evolution and revolution. Really, the cloud evolution has substantially changed how security teams are managing security in their environments. Security teams used to have also physical security part where they needed to look after the data centers. They needed to go look after actually their hardwares. And came along cloud where simply it just was things weren't running in their environment anymore, and the security teams were looking into simply a different solution space. And to be very frank here, and obviously it's sometimes about us security teams and security personnel. It's not easy to talk about it so bluntly, but sometimes even with security engineers and teams, we didn't really understood what cloud was, where the responsibilities, and when the responsibilities start on our side. We didn't really understand how the cloud provider worked at the beginning. And on the other hand, other existing solutions, firewalls, even endpoint security solutions didn't really fit into that concept. And also operation teams were really reluctant to deploy existing solutions into the cloud environments. And came along solutions which we call today agentless solutions. Agentless solutions that came and said, well, we don't need anything else to protect your environment. Just give us access to your AWS account. We are not going to install you agents on every machine. We are not going to deploy you a firewall. What we are going to do is just talk to the AWS API or Azure API or Google API. And from that, we'll give you a security control plane where at least you can, see what's happening in your environment. And this is the phase where we came to call it posture security. So instead of managing runtime security in its very, very classical meaning, what we meant is, sorry, someone is playing with my slides. So we really started to look at, okay, what the operations team had deployed in the cloud, and trying to go after their deployments, understanding the security level of their deployments. Obviously, the speed of the deployment have changed because of multiple reasons. I don't want to go into it, but everyone understands how modern application version updates are working. And therefore, agentless solutions were a good solution. But on the other hand, as I'm going to show you later today, looking at posture only has its own challenges. And therefore, we are getting into the year 2020s, where, as I see it, and I think a lot of people will back up me later, simply we cannot look at the posture without returning somewhat to the runtime as a security team. So as we came through the time looking at runtime, firewalls, endpoint security, came into the cloud and started to look at only at the posture, and we understood that only looking at the posture as a security team is not enough, and we are going to return to runtime as well, together with the posture, to make the world better. So why posture security alone is hard? And I'm going to bring you here a few examples. So one of the things that today many security teams are dealing with on a day-to-day basis is vulnerability management. Vulnerabilities are coming up every day. I don't know the exact number, but it's in the more hundreds of, if not thousands of new vulnerabilities are published every day. And one of the most best well-known best practices is to make sure that your software is up to date with all the vulnerability patches. And one of the ways to enforce it is to scan for vulnerabilities in your environment, and making sure to push the operations and development teams to take the latest patches and deployment them one by one. Now, the problem with that is, if you're looking at vulnerability management, and as I said to you, vulnerabilities are coming up in hundreds and thousands, hundreds, if not thousands every day. Vulnerability management is really hard because simply there are just so many things to look at, and they are very hard to differentiate. So if I would ask you to look for Waldo in this, for the real Waldo in this picture, you had really hard time to do that. Now, when I prepared these slides, I ran some, through our ARMO, in our databases where we are managing vulnerabilities for a lot of customers. I've checked what's the average number of vulnerabilities a customer has right now in his system. And if you think as an average of our customers who are ranging from small or organizations to very big organizations, if you see that there is 13,000 vulnerabilities that hasn't been patched in their environment, it means that it's a pretty hard time for them to manage these vulnerabilities and decide what needs to be patched and actually doing patches. It's a very, very long time, very, very tedious work to do, and it's very, very hard to manage this number. Obviously, it's not just our work as security engineers and persons and operators to fix it. We have to identify these vulnerabilities. We have to decide which one of them really counts, which one of them has really, which one of them can cause problems, and obviously have to go to either operations or development teams to have them patched in time. Now, if you think of that how can I manage as a security team? How can I understand, to fix them and to prioritize them? It's very easy to say today that, okay, well, I just don't care. I'm a security person. If there is 13,000 vulnerabilities in my environment, I will open just 13,000 Jira tickets for my R&D or for my engineering team and let them fix it. But obviously, this is not something that's going to work because they won't be able to prioritize that. It will fall back on me, and obviously, these are not the numbers that can be managed. Obviously, if we are looking at just the very basic prioritization technique of looking at the CVSS scores of the vulnerabilities, we see that it's not really helping too much, because even if I'm not looking at 13,000 vulnerabilities, but I'm saying that I only want to fix the critical and highest severity vulnerabilities, 3,000 vulnerabilities is still a lot. Still something that's hard to execute on. And then, if we ask the real question here of, okay, I have this a huge number of vulnerabilities based on the versions of my software packages, based on the most latest vulnerability databases from NVD. Which of those can really be used to penetrate my system from the outside? Which is really causing me a real risk in the environment? And it's really, really hard to say. I couldn't create any actual statistics because it's very damn hard. But it is well known, not well known, but an accepted number that it's less than 1/10% that in these environments can be exploited among these vulnerabilities. So this means that there has to be something really, really flawed in looking only at the posture scanner output or vulnerability scanner output in this case. So let's take a look at another example. Other things that posture management tools are doing is actually scanning the configuration of cloud assets and looking for maybe security misconfigurations in them. So when we are looking into these assets, I have let's try to make this run. So when we are looking at cloud assets, it's very, very hard to make them understand, okay, which one of these are problematic. Scanners are returning. Sorry for here. I should have here a video, which doesn't seem to be playing. Never mind.
Wait, let me see if I can do that. There you go.
So it's very, very hard to understand what's the point of every cloud asset. One is the probability of potential security risk in their configurations to our environment. Sometimes us security practitioners doesn't really understand which one of them is really which one of them is really hurting us, and if we can, whether we can change this and improve the posture of them. Therefore, it is really hard again to manage only the posture without understanding of the context of what is going on. And again, when preparing these slides, I created these statistics based on our customer database, and we see that nearly every cloud object a customer in our system, the customers has a potential security misconfiguration. And it's a very huge number, given that an average customer has more than 10 or 20,000 cloud assets in our environment. It is really, really hard to manage and understand from a security perspective what's happening here. And it's sometimes really, really easy from scanners to give you information on potential security problems in a cloud assets. Even that one of the classical examples of privileged containers running in a Kubernetes cluster, if we would simply remove the privilege flag and say that, okay, from now on, to solve this potential security risk, we'll simply turn off this flag. Most likely, anyone who's in operations will know that most likely this container won't work and will simply hurt the functionality of the environment because we simply don't have enough information just from a static scanning perspective of whether this container requires these privileges or how could it be optimized. We need for that R&D and other inputs to understand that. So as I see it, one of the reasons what can really improve the posture management in general is actually the runtime context. And this is why I said that before that as I see there is a convergence from posture management back to the runtime and having the best of both of these worlds, because as I see it, as we see it, this is something that really can elevate the way that security teams are working today or worked even before. And I'm going to go over, two major areas of solutions. One is that I'm returning to the part of the vulnerability management. So when you're managing vulnerabilities in your environment, most likely you have either an open source tool like Trivi, scanning vulnerabilities in your container images during your CI/CD processes, or you have a registry scanning setup where you have a scanner that scans your container images in your registry or in your AWS nodes or EC2 nodes, and you get a ton of vulnerabilities. Like in average, most of the workloads have more than 100 vulnerabilities in them. And as I'm returning to my original point that it's really hard to manage this number, because looking into the actual work and see whether these things are worth to fix, and if they need to be fixed, where to fix them, and how to fix them, and how much time it will take to fix them, and actually execute the upgrade and do the test is a really, really expensive thing to do, and not just on the security side, but on the engineering and operations side. So these are some things that are very, very hard to do. And I'm showing here to you, our open source project, Kubescape, which is actually a Kubernetes security project, that one of the features of it is actually container image scanning in Kubernetes clusters. it constantly scans all the images in the Kubernetes cluster for vulnerabilities and produces output to Kubernetes CRDs objects, and from there you can take the output anywhere. One of the things that really bothered us was actually this point of having too many vulnerabilities, and therefore we decided that 2 years ago that we want to make sure that the vulnerabilities we are returning to the user for later processing are actually vulnerabilities that part of software packages that are using during the container runtime. So not just scanning the static container image, but looking at the container in runtime, we are using eBPF to capture the activity of the containers during runtime, see which software packages are loaded into the memory. And using this information, we know which software packages are actually in use during the container runtime. And instead of returning all the software packages and scanning all the software packages for vulnerabilities and giving a huge list of vulnerabilities, we are scanning only those software packages that has been used in the runtime, and they can be exploited. This is something you have today in our open source in Kubescape. And just to give you a very early example, and this is the number I usually in every of my presentation I'm bringing here, because this was our POC. We took Redis, the standard stock Redis image we had 2 years ago. We saw that we have nearly a little bit more than 150 vulnerabilities in the latest Redis image we had back then. And we only saw that only out of the 150, only around 15 which were actually loaded into the memory. Most of the highs and all criticals have disappeared. All the high were only reduced to 1, and only a few negligible severity vulnerabilities stayed with us. So we saw here a 90% reduction in the scanner numbers, which is a huge gain if you look at the vulnerability management perspective. So when we bring this into real life situation, not just a single image, but in general, we use this runtime context to get I would say a rough filtering of which are the vulnerabilities that has a chance to be exploited at all. I'm not saying that they can be exploited, but at least they have a chance to be exploited. Is sometimes less than, even with our simple filterings, are less than a percent of the all vulnerabilities you have. So if you look at the screen, you have this this risk spotlight bulb here on the top of the screen, where you can see that in this environment, which is a small environment, we had around 5,000 vulnerabilities in the connected Kubernetes clusters and cloud assets, and using the basic filtering of which of them is in use, which of them is exploitable based on exploitability metrics like EPSS. We could reduce the number of the vulnerabilities that we have to manage from nearly 5,000 to 23, and 23 is already a number in such an environment that can be managed and can be handled by the team. This is something that I can address and I can have the team to fix within a foreseeable future. And this is like simply adding the runtime data to the static posture scanning, and together we had a huge reduction because we have now the runtime context and understanding of what's happening. Going into another example here, You remove this. So going to the other example of configurations and policies. Sorry, I'm just going to drink here. So I'm going to bring you here 3 other examples in the configuration policy work. One is the workload, the optimization of this from a security perspective of our workload configurations. The second is network policies. The third is SecCom policies. All these things can be done without runtime context. All these things, we can optimize your workload security manually, just looking at the static scanning results and have the developers working with you and sorting out with you all your questions. You can have the same defined network policies based on understanding of who should be talking to whom. You can define SecCom policies as well based on how the workloads are working. But in the real world, it is really hard to do that. And again, what we do is we're with Kubescape, our open source project, we use eBPF. We use eBPF in order to understand how do actually workload behaves, what kind of files it accesses, what to whom it talks to through the network, what is the actual system call activity in the workload, what kind of system calls it uses against the kernel, and we get a full picture of the application behavior from these perspectives of the workload. What it enables us, that I'm giving you here an example, is to answer the simple question of whether a workload should be allowed to have privilege escalation during its runtime. This is again a very, very standard configuration test in containers. It checks whether the container was run with a flag of allowing privilege escalations, meaning whether it can call sudo during its runtime or not. The default setting is that this is allowed, therefore it's by default turned on, therefore you are getting a bunch of alerts on each of these workloads. But you as a security practitioner don't actually know whether this workload needs to have to be allowed to have privilege escalation because you don't know how the workload works. If you're just turning it off, you might break the application. And it's a very, very bad approach. And here's where the runtime context can help you. If you have the runtime context, you know actually which processes run during the runtime of the container and how they are run, how they are invoked. You can understand whether the actual during the runtime privilege escalation is needed or not in order to the application to work. And if it doesn't, then you can safely disable this flag. And as you can see here in this example, you can see that our analysis indicates that you can safely disable the allow privilege escalation flag because your workload does not use this capability. So we took the actual workload behavior and proposing here the fix based on how we see that the workload behaves. And it saves a lot of time for a security practitioner because now he knows that he can change these settings without breaking the application. The same goes for other examples. For example, in this case, there is a mount from the host to the container, which is generally thought to be a very bad practice generally. Means in this case, if you can see that on the left side of the YAML is mounting, the original YAML is mounting a Docker socket into the container. But based on the runtime analysis, we can say that actually the container uses this file during runtime, therefore you can safely remove it. So then you can right way optimize the workload without breaking the application. Another example is network policies. So when you need to define network policies in your environment and need to do some kind of a micro segmentation project in the environment, you can create very generic rules that if you know that there are workloads that doesn't need to speak to the outside world, you can block communication to the outside world. But in general, in a microservice architecture, it's sometimes really, really hard to know as a security practitioner which workloads are talking to which workloads in the environment. And therefore, Again, if we're taking in the runtime observability and security observability information into account during the runtime, and we understand that this web shop, in this web shop namespace, the workload frontend is talking to kubedns and recommendation service and cart service, this means that we can define actual network policies based on the actual workload behavior and lock down the current behavior as the baseline policy for environment, without the need to actually involve the cloud architect, the application architect, the developers into the thing, and understand and roll out a working policy. Now, in this example, in ARMO, for example, we are right away producing actual policy objects for Kubernetes, Cilium, Calico, depending on the network CNI you prefer. Now, another thing is, and there's a problem because I cannot do here a quick question around everyone that who knows what seccomp profiles are in container runtime and container security, but I will give you a very short intro to that. Seccomp profiles are a way to limit the system calls a container can do against the kernel in the container runtime environment. This is a way which, from my point of view, most of it is for a security perspective. It's a very good way to protect your node against malicious code which is executing in your containers. Container can be penetrated either by an external exploit or a supply chain attack, and an attacker can start to try to escape the container boundaries through a kernel exploit. And seccomp is a good way to limit what a workload can do, which kind of operations a workload can request from the kernel. And it's very good in limiting those kernel exploits. The problem is that sometimes it's very hard to define good seccomp policies, because either you're taking a very generic seccomp profile, which has the problem of one size fits all. If it can be over permissive or too string, and most of the time, in order to make the things work, you will choose some kind of seccomp profile that is over permissive. But there is a third way, which is actually making your own seccomp profile, which will enable only the system calls that your container needs to do in this environment. And here again, the security observability can be very, very helpful, because we can say to you for sure which are the system calls that your container does during the runtime. Using this monitoring, you can turn the actual workload behavior, just as with network policies, you can turn it into actual policy of seccomp profile, and apply the seccomp profile right away from here, and deploy it to workload in a way that's much, much more secure for the environment than running the workload without. So, to summarize the discussion, one of the things that we are big believers here is that both sides of the world, both the runtime and configuration and posture, and both the runtime, both of them are very, very important cornerstones of the modern security world. But these things cannot work. Not working them together is just a big miss, because the runtime can help a lot with the configuration management and posture management. And on the other hand, which I haven't talked about it today in this context, but also the posture and risk management can help a lot to runtime to focus the runtime detections in a big way. So we are big believers that these things are converging together, and I showed you here a few examples of how runtime security context can help you actually make your improve your posture in a way you couldn't do it a few years before. Thank you very much, and I'm opening here for questions.
Wow, I mean, I don't even know where to begin. We have some great questions, and one of the ones that I was also interested in is, how do you filter vulnerabilities that scan that you don't just use critical, for everything?
So, so first of all, I will try. I'm not really 100% sure that I understand the question, but I will try to understand answer in a broad way so I will hit the answer correctly. So using only critical is a big problem today, because how do you know that if you are filtering out all the non-criticals? On the one hand, how do you know that you haven't filtered out a high severity vulnerability that can also be exploited, and the end result is going to be the same? The risk is the attacker will be able to penetrate even with sometimes with a medium severity issue, not just a higher critical. Therefore, it's a good prioritization mechanism, but it's not a definite prioritization mechanism. On the other hand, what if there is a critical vulnerability, but in your container image, but this it is part of a software package that it's not used. Actually, it's not run. Therefore, an attacker cannot exploit it, or I would say, in a very, very, very rare situation, an attacker can exploit a vulnerability that is in a container image and it's not part of the actual runtime which is used. So in that case, if you prioritize the critical vulnerability to be fixed, you would just fix something that cannot be exploited. But therefore, returning to what I tried to say before, it's nearly impossible to tell whether a vulnerability can be exploited or not, but there are very, very good ways using runtime context to filter out a lot which are rarely can be exploited. So runtime context helps you to prioritize things. It doesn't have a definitive answer for everything, but it has a good answer for prioritization, a very good answer for prioritization in general.
Indeed. Yeah, thanks for that. So how long do the workloads need to be monitored by eBPF runtime to get reliable data?
So it really depends. It's not, there is no general answer to that. So if I would try to, rephrase this question, I would say, how long, how long it is enough to look at the workload behavior to say that you understood how the workload behaves, and it really depends on the specific workloads. We tend to configure environments to look at 24 hours on workload behavior and collect data at least for 24 hours to catch all daily operational procedures in every workload. To see how the behavior, and I would say around 24 hours should cover most of the cases.
So here's an interesting question. What happens if a workload changes behavior after the monitoring time ends? And, for example, loading a new software component after the 24-hour period, after a day.
So again, this is I would say from this point of view, let's say I saw 24 hours of workload behavior and say, okay, now I understand how this workload behaves. Now it loads an extra software package into the memory, which it's allowed to. You cannot say it won't happen. Then in that case, this software package and its behavior and its vulnerabilities will be missed from the prioritization list, will be missed from the network policy, and so on. But again, this is more of the question of how representative your environment is and how its behavior is representative. I tend to say to customers who raise similar questions is that I organize in my environment, and I've been using such tools for years in a way that they are covering also my tests. So during my component tests, I'm running these monitoring tools, and since monitoring tests should cover all cases of the software behavior. I expect to see all these behaviors there, and therefore they are giving reliable data. But again, this depends on the test coverage of the given environment.
Indeed. The next question is, do organizations trust the quote unquote in use property when doing vulnerability analysis?
So whether I'm reiterating the question, whether actually security teams are trusting this in-use capabilities. So yes and no. I think that everyone who is actually doing day-to-day work, they are really looking for such features. Therefore, I see that more and more teams and organizations are adopting it as a definitive property. On the other hand, I think that mostly compliance and because of compliance and other reasons, legal reasons, there are still a lot of organizations who use them as a prioritization tool, but still cannot take this fully into account and need to solve also things that are not in use, because there is still a catch up in the compliance frameworks and agreement level and SLAs that need to cover this property and adopt it. So to help security teams to focus on the real things.
Indeed. And as we're beginning to wrap up, one of the things that crossed my mind was, as part of your amazing background, you are a teacher, a lecturer, you educate people. How do you distill the complexity of everything that you've been talking about to an undergraduate level, and even maybe if you can compare then a graduate level? I mean, how much detail can the kids absorb?
So good question. So I think that I would start by comparing the graduate and undergraduate level. I feel most of the time that usually I'm teaching at graduate level people who have already had some time in the industry, like a year or two, and has some kind of a sense of how actual organization is working, how engineering organization is working, and therefore they have the sense of understanding of why these things are important. So when I'm teaching them security in practice and why they need to invest here and there and why it is hard to roll out a fix in one of the hotfix in one of the vulnerabilities, they start to understand. They understand why it is a problem, right? While an undergraduate student who never really faced these problems, they have hard time to understand. I can tell them that, well, it takes time to update a software image, because it's not just like doing a patch and just like push out and roll. It needs to be tested, it needs to be approved, it needs to go through ticketing system and so on. And sometimes it takes a lot of time, and they nod like this, but they are not really understanding why.
Yeah, indeed. Well, I failed algebra, so it's above my head. So lastly, how does our audience and others learn more about you or get in contact with you?
So I can be called either, most of the time, if someone wants to chat with me, I prefer Slack, either CNCF or Kubernetes Slack. These are two Slack workspaces that are free, and you can freely join and find me there and just ping me. Or you can ping me on LinkedIn, but I'm less responsive, to be frank, on LinkedIn for obvious reasons. And just the best is to catch me on Slack.
Well, thanks so much for who you are, for what you do, and why you do it.